We actually raised our seed round from Mark Cuban, which was a cold email like a week after we said we're starting a company, and then he gave us our entire seed round within this.
You cold emailed him?
Yeah, we cold emailed Mark Cuban with the email tagline, space is sexy, 3D printing an entire rocket. There was like 2 months of due diligence after, but he gave us $500,000. That was like our first investor we talked to. So subsequent rounds were certainly.
That was a good email. Are you a 3D printing company, or are you a launch provider?
Yeah, so we are a launch service provider. So a satellite company that wants to launch to space would give us their satellite and say, put this on a rocket and fly it at this date and this time. But we've also built what is the world's largest metal 3D printer ourselves to actually print an entire launch vehicle as well. So it's a way to make that service much cheaper and faster to access.
So I guess maybe I'm not fully understanding the advances that have come in 3D printing. I mean, what can't you print? If you're printing the engines and the rockets, I mean, that's basically like 99% of everything. I mean, besides the fuel, is there something that is non-printable?
Yeah, so we're printing about 95% of the parts on the rocket. So the 5% we're not are electronics, computer chips, what are called harnesses or electrical cables that connect everything together. And then also there's some rubber kind of sealing parts and valves that we're not printing. But everything else is printed and designed from scratch for this new method we've come up with. So what we've hit to date, we've actually tested our 3D printed engine at NASA's Stennis Space Center over 80 times. And we actually did our 81st test 10 minutes ago, and it was a success. So we have done a lot of engine testing. We've built what this very large printer is. Expecting first flight in kind of the late 2020 timeframe. But really, we don't think this is a market that's, you have to be first to market. We want to build at Relativity the launch vehicle that's like last to market, much like Google was like the last search engine. And that's just because rockets are so economically and kind of dominated by physics and the economics of how much labor goes into a rocket. How big it is and how much payload it can take, that coming up with what we think is the best long-term process that will be the best process even 50 years into the future is really what we're going after.
So is Relativity's value proposition just that you can do this cheaper because you're 3D printing the rocket, and so you're saving an enormous amount on labor costs?
So it is cost, but actually more important than cost, because you can imagine, I mean, we're not the only player going into the launch space as a startup. There are other companies that are venture-backed and have solid funding, but we're really creating a new way to make rockets that iterates much faster. And that's very, very important in the long run. So it takes us about 60 days to build a whole rocket once we fully developed our technology, which is crazy fast. Like that compares with 18 to 12 months for a traditional process. And then you have a factory with kind of a set amount of tooling that can't really change and morph with the design. Versus for us, our factory being a 3D printer, we really view as software-defined automation.
Are you in the Mars camp?
Yeah, I'm more in the Mars camp personally, just because, I mean, it is true that, if you're actually talking about building a city that's going to be self-sustaining, Mars has the best conditions to do that. The only disadvantage is that it is further away. So if you're going to test technologies out, everyone looks at the moon and says, well, it's so much closer, you can see it. It only takes a few days to get there instead of months.
Depending on the orbits, right?
Depending on the orbits, yeah. So I think that's kind of the unfortunate thing that makes the moon look very attractive near term to be able to go to. But yeah, I'm Camp Mars.